I didn't actually get that connection, so I didn't really know.
Right. So, exercise 1. Can we just run through these one at a time? Sulfur on its own.
0.
SO2
Plus 4.
plus 4. H2S.
The rest as well? Minus 2.
It's always sulfur we're looking at here, yeah? S2 minus. Same as the charge on the iron, rule number 2. Okay, a bit more interesting. Sodium, well, it used to be called sodium sulfite.
4.
Yeah, so just to unpack it a bit, sodium is +1, there's 2 of them, so they're contributing +2. Oxygen is -2, but there's 3 of them, so they're contributing -6, and the whole thing has to add up to 0, so sulfur must be +4. Calcium sulfate.
-6.
Let's just unpack that one as well. So calcium's in
Group 2.
group 2.
I got +6. I got +6. Oh, this is -8.
Yeah.
Oxygen -8.
Oxygen is
-8.
yeah. So the oxidation state, you get into trouble if you say oxygen's -8. The oxidation state of oxygen is -2. There's 4 of them, so they contribute -8 in total. Yeah, and then sulfur is what it is, but the total has to add up to 0, so sulfur has to be
+6.
grand. HSO4 minus. +6 again. So we've got H, rule number 5 is +1. Oxygen -2 again, but there's 4, so that adds up to -8. Sulfur is what it is, but the whole thing has to add up to -1 now because we're looking at a compound ion. So yeah, again, sulfur is still +6 there. And S2O32 minus, the thiosulfate ion.
+2.
Okay. This is an interesting one. So sulfur, we just have to bear in mind there's 2 of them. Oxygen's -2 and there's 3 of them. So oxygen in total is contributing -6. The whole thing has to add up to -2. So sulfur must be contributing +4. So each sulfur must be +2. But here's the thing. If we look at the sulfate ion, right? Sulfate is, we saw a sulfate, we saw calcium sulfate there, didn't we? The sulfate ion, SO42 minus, consists of the sulfur surrounded by 4 oxygens, and 2 of them have a charge on, which is why we have a 2 minus. So the oxidation state of sulfur there is +6. S2O3 is thiosulfate. The word thio, it's an old word for sulfur. So thiosulfate is actually sulfur sulfate because one of the oxygens has been replaced by a sulfur. Now the oxidation state of all the oxygens is -2, right? So that sulfur has an oxidation state of -2. And that sulfur still has an oxidation state of +6. So why do we get +2? Can anyone see what's happened? what we call a deafening silence.
Just try to figure it out. I wasn't really listening to him. I didn't hear what he said.
Thanks for your honesty.
-4.
The oxidation state of that sulfur in thiosulfate is -2. The oxidation state of that sulfur in thiosulfate is +6. But when we work it out, we get +2. Why?
+6 -4.
+6 -4.
Yeah, +6.
Not quite it, is it? Anyone see the relationship?
The two oxygens. No. Yeah. Because the sulfurs are +6 anyway.
Well, that sulfur's +6 and that one's -2. So why do we say +2? I'm just going to leave that hanging. Let's do nitrogen.
Oh yeah, good idea, Sean. Just don't mind it.
Where do we get up to? N2 gas.
I got 2.
Nitrogen is an element. N2O4.
4.
Thank you. HNO3. I think we did that in the example, didn't we?
Yeah, I didn't get up to.
Oh, okay.
+5.
We're up to it now.
We shouldn't have done that.
H is
+1.
+1. Oxygen is,
-2.
but there's 3 of them, so,
-6.
and the whole thing has to add up to,
0.
so that nitrogen must be
+5.
grand. KNO2
+3.
+3. Thank you very much. N2O5
+5.
+5. Lovely. NH4 plus
Okay. -3. Oh yeah.
Mg3N2.
-3.
You've got
-3.
-3 and N2H4
-2.
Okay. So you can see from that the extent to which nitrogen and sulfur can, get around. But that can be helpful if you're looking at a big equation, like we were earlier. Let's just stick that one up here. HNO3 goes to copper, nitrate, and NO2 and H2O. 2H2O. If you're looking at a big equation and you're not sure what's being oxidized and reduced, well, sulfur and nitrogen are often a good place to look because they can vary their oxidation state a lot. Let's just have a go at this one. Oxidation state of nitrogen in HNO3. Just covered that, haven't we? +5. Oxidation state of nitrogen in nitrate helps to remember the nitrate ion is a compound ion with the formula NO3-. It's the same. So that's how we know that nitrogen hasn't changed its oxidation state there, but for NO2, +4. Okay. Just change pen. Copper over here, oxidation state is 0 because it's copper the element. Copper nitrate, again it helps to remember that the nitrate ion is NO3-, so copper must be +2. And here's the very, very simple rule. If the oxidation state for an element has increased, it's been oxidized. And if the oxidation state for an element has reduced, then it's been reduced. So oxidation states will help us identify what's been oxidized and what's been reduced in an equation, which is where we are going to go next. Let's just go back to thiosulfate. Any ideas?
No idea.
What's the average of +6 and -2? You work out an average value, yeah, for a compound. So even in a compound where you get different oxidation states for the same element, they'll average. But you know what? It doesn't matter. It'll still work as a tool. We can still use it to solve problems.